Hello everyone, I am Kranthi Kumar, Assistant Professor in the Department of Electronics and Communication Engineering, Marri Laxman Institute of Technology and Management. In the previous lecture, we discussed about the voltage and current characteristics of P-N junction diode. So in this lecture, we are going to be discuss about the diode resistance. Diode resistance. The topic name is diode resistance. So a PN junction diode allows electric current only in the one direction. So and blocks electric current in the other direction. Which means so when we are connecting the PN junction diode in the forward bias condition, it allows the flow of electric current. So when we are connecting in the reverse bias condition, so it will not allow any amount of current. So which means it is going to be works only in the forward bias condition. Okay, so that's why, so here we are mentioning an PN junction diode allows electric current only in one direction and blocks electric current in the other direction. So okay, so it allows electric current when it is forward biased and blocks electric current so when it is reverse biased. So in the reverse bias we are not get any electric current in the PN junction diode, right? So the depletion region which is present in the PN junction diode will be act as a barrier to the flow of electric current. Hence, it offers some amount of resistance to the flow of electric current. Right. Also, the atoms present in the diode so provides some amount of resistance to the electric current. Right. So the depletion layer which is present in between your p-type and n-type material so will offer some amount of resistance. Also, so the atoms which are present in the p-n junction diode also gives some amount of resistance. Right. So when a forward biased voltage is applied to the p-n junction diode, the width of the depletion region is decreases. But so in practical, so the width of the depletion region will completely vanish. Okay, so there exists a thin depletion region or a depletion layer in the forward bias of a diode. Therefore, a thin depletion region and the atoms in the diode offers some amount of resistance to the flow of electric current, right? So when we are connecting a PN junction diode in the forward bias condition, so the width of the depletion region is not fully vanished. So a small amount of thin depletion layer will be present in the PN junction diode. So this thin depletion region will provide some amount of resistance. Also, the atoms present in the PN junction diode provides the resistance to the diode. So when we are connecting a PN junction diode in the forward bias condition and reverse bias condition, so in these two biased conditions, the resistance will be there. So we have two types of resistance takes place in the PN junction diode. So that is forward resistance and the reverse resistance. So the first one is forward resistance. So forward resistance is a resistance offered by the PN junction diode when it is forward biased. So in a forward biased PN junction diode, so two types of resistance takes place based on the applied voltage. Right. So the two types of resistance takes place in the forward biased diodes are, the first one is static resistance or DC resistance. So dynamic resistance or AC resistance. Okay, so based on the applied voltage, so we have two types of resistance takes place in the PN junction diode. The first one is static resistance or DC resistance. The second one is dynamic resistance or AC resistance. So coming to the static resistance or DC resistance, so when a forward biased voltage is applied to a diode, so that is connected to a DC voltage or current, then some amount of current will be flow through the diode. So the direct current or electric current is nothing but which means the flow of charge carriers, that is the either electrons or holes only in the one direction, right? So the resistance offered by the PN junction diode when it is connected to a DC circuit is called a static resistance. The simple definition for a static resistance or DC resistance is, so static resistance is defined as, so the ratio of DC voltage across the diode to the DC current or the direct current flowing through the diode, which means as per Ohm's law we know that V is equal to IR. So from this we can write R is equal to V by I. So here we are applying some DC voltage to the PN junction diode, that is equal to, so DC voltage, the ratio of DC voltage to the DC current. The ratio of DC voltage to the DC current is nothing but the static resistance or DC resistance. So when we are applying a DC voltage to the PN junction diode, it will offer some amount of resistance. So that is called static resistance or DC resistance. So on the DC resistance, we are going to be solve a problem. So now we have to find out the DC or static resistance for these values. So by using this graph, by using these IV characteristics of PN junction diode. So in the first one, so ID is equal to 2 milliamps. So it is given in the problem, and so VD is equal to 0.5. It is taken from this graph. Here even the current is 2 milliamp, so the corresponding voltage is 0.5 volts. By substituting in this equation, RD is equal to VD by ID. So we know VD value from the graph, that is 0.5. Now ID value is given in the problem 2 milliamps. By substituting these two values in the formula, we will get, so the DC resistance is 250 ohms. Okay, in the second one, ID is equal to 20 milliamps. So if ID is equal to 20 milliamps, this is the ID value 20 milliamps. The corresponding voltage, what is the voltage here? The corresponding voltage is 0.8 volts. The corresponding voltage is 0.8 volts. So now 0.8 by 20 milliamps, now we will get 40 ohms, right? And the third one, so VD is equal to minus 10 volts, which means the reverse voltage, right? So for minus 10 volts for reverse voltage, so the corresponding reverse current is 1 microamp. If you observe here, minus 1 microamp. Okay, so minus IS, which means reverse saturation current, is equal to minus 1 microamp. By substituting this equation, so 10 volts by 1 microamp, that is so 10 mega ohms, which means the reverse resistance is more compared to the forward resistance, right? So it is a simple problem solving. So next, coming to the dynamic resistance. So the dynamic resistance is the resistance offered by the PN junction diode when an AC signal is applied. So the simple definition for a dynamic resistance or AC resistance is the ratio of change in voltage to the change in current. The ratio of change in voltage to the change in current. Why? Because here we are applying an AC signal, so which means it is a time varying signal. The voltage is varying with respect to the time, so we will get different voltages at different time slots, which means if you are varying the voltage, then current also will be going to be vary, right? So the ratio of change in voltage to the change in current, it can be right like VD, delta VD by delta ID, that is RF is equal to, it's the simple definition of dynamic resistance. Now we are going to be solve formula equation for a dynamic resistance. So it is the derivation for a dynamic resistance. So I can show how it can be solved. So we know the diode resistance I V is equal to IR. From this, R is equal to V by I. Now we are going to be find out the resistance when we are applying some AC signal, right? We know the diode current equation, ID is equal to IS into e power VD by neta VT minus 1, right? So okay, so now we can write this above equation, Is e power Vd by neta Vt minus into Is. So consider this is equation 1. Okay, so now I can write the above equation like Id plus Is is equal to Is into e power Vd by neta Vt. This is consider equation 2. So now we have ID value. Now we need Vd. So differentiate equation 1 with respect to Vd, right? So what will dId by dVd is equal to, okay, so if you observe here, is the reverse saturation current, it is a constant, so I can take it out, is into, so d by dvd, so e power vd by neta vt minus 1, right? So by implementing this, we know that the differentiation of e power ax is equal to, so a into e power ax. By using this one, we are going to be implement this one. Okay, so is into, so what we can write, we are doing the differentiation with respect to vd, that's we will get 1 by neta vt, right, into e power vd by neta vt. So the differentiation of this constant value is 0. Okay, so now we can write this equation, so d id by dvd is equal to, okay, so 1 by neta vt into is into e power vd by neta vt. Okay, so we know that we can reframe this equation. So we know that from equation 2, so is into vd by e power vd by neta vd is equal to what, id plus is. Okay, so from equation 3, from equation, sorry, from equation 2, so what we have, so is into e power vd by neta vt is equal to id plus is. Okay, so now substitute this one in the table. If you consider this is equation 3, okay, now substitute, okay, now in equation 3, so what we will get, that is equal to 1 by neta vt into id plus is. Okay, so that is id plus is by neta in by vd. What is it? Is the differentiation of id with respect to vd. So we know that the reverse saturation current is very less. Okay, so id is, which means we have the reverse current is very low compared to the forward current, that is id is greater than is. Now we are going to neglect this reverse saturation current. Now I can write this equation, did by dvd is equal to id by neta vt. Okay, so but we know that r is equal to v by I, so in v, okay, now we can write the above equation like dvd by did is equal to, so neta vt by id. So it is the equation for dynamic or ac resistance, right? So the same thing here, so did with neta vt by uh, id, right? Next, reverse resistance. So the reverse resistance is the resistance offered by the p junction diode when it is reverse biased. So in the reverse biased p junction diode, so when we are connecting this p junction diode to the reverse bias condition, so the width of the depletion region is increases. So here the width of the depletion region increase means, so very less amount of current will be flow through the p junction diode, almost it is negligible, which means the depletion region offers very high amount of resistance in the reverse biased condition. So that's why the reverse resistance is in the range of mega ohms. So compared to the forward resistance, so the reverse resistance is very high, so when it is forward biased. Okay, thank you.